When we first learnt about sine, cos, and tan, trigonometry, you were probably told it's about triangles. That was a lie. Trig is about circles. We can only deal with trig for angles less than 180 degrees in triangles. Unit circle lets us deal with angles to any size we could possibly want, and it really deepens our understanding of sine, cos, and tan. So it's going to be the biggest paradigm shift we've seen in this whole topic, and probably your whole mathematical life. Let's look at the unit circle. This is the unit circle because it's got a radius of 1. And it's sort of put on the Cartesian plane, like an x-axis and a y-axis here. Okay, whenever we measure angles on the unit circle, we measure them coming out anti-clockwise from the origin. So that would be an angle theta there, for example. Always that direction, always anti-clockwise. Okay, so let's look at an example. If I make this angle here, my beautifully drawn 30 degrees, I have no idea how accurate that is. The natural question would be, how wide is this triangle? And how tall is this triangle? And in fact, I guess a more natural question would be, what the heck are these coordinates here? Okay, so let's do some investigation. We know a bit about trig already. So we know that this is 30 degrees here on that triangle. I said before the circle has a radius of 1. So in fact, this length here must be 1. That's the radius of the circle. So let's see if we can calculate h for height. Well, we sort of can, because we can label this triangle as opposite and hypotenuse. So all of a sudden, we have got sine of 30 equals h over 1. Okay, so yeah, h is just sine of 30. Cool. Wonderful. Now we can also calculate the width of this triangle. There's a width. There's 30 degrees. The radius is still 1. So let's label it. We've got adjacent and we've got hypotenuse. So cos of 30 is w over 1. Or in other words, w is just cos of 30. Oh my goodness. So all of a sudden, this point here, the coordinates are, well, the x value is cos of 30, and the y value is sine of 30. And you may have also noticed it didn't matter at all what that angle was. You're always just going to get cos for the x value and sine for the y value. So that is really wonderful news. In fact, that is our definition of cos and sine. That's how they should be defined for starters. And SOHCAHTOA is a consequence of that definition. It's just the way you tend to learn it in school is in reverse. All right, so if we look at the unit circle here, you can see that we sort of start from this angle, which is very low. That green distance is sine, so it's about 0.7 up here. That's the y value, that's the height of the triangle. The width of the triangle is cos. So cos starts off at 1, and then it sort of wraps around. Cos eventually becomes 0. And it eventually goes negative, that blue number, because we're on negative on the x-axis. So if we just draw a couple more unit circle examples, we can have a look. So if I make an angle here like, let's go 110 degrees. It's a little bit bigger than 90. I don't know exactly what the cos and the sine values are going to be, but I would expect that maybe the x coordinate here is maybe minus 0.3, something like that. Because the x coordinate down here is minus 1. And here the x coordinate is 0. So I'd expect it to be minus 0.3 maybe. And the sine value looks very tall. The height looks very tall, 0.9. So in particular, the height of this triangle does look like 0.9. It's almost 1 tall. And the width does almost look like 0.3. So if we use our calculator and we try and work out in degrees, cos of 110, I'm hoping that it should be roughly, hey, minus 0.3. Well, that's good. And if we work out sine of 110, hey, about 0.9. That's good. It's very rough, but it should give you the idea. Okay, more unit circle stuff. Now, I am going to jump to radians here. I apologize that we've only just learnt radians and we're jumping to it, but you tend to use radians rather than degrees for trig. So I'm going to make this angle up here of pi over 2. If you want, that's the same as 90 degrees. I am expecting, because this point's right on the top, I'm expecting that cos of pi over 2 is actually 0. So it's that x coordinate there. And I'm expecting that sine of pi over 2 should equal 1. There it is. Now, we better make sure our calculator is in radians. So shift setup. I'm going to go all the way over to radians. And let's work through it. So cos of pi over 2. Now, when you do that on your calculator, make sure you bracket it before you do cos of pi over 2, otherwise you get the wrong answer. 0. Sine of pi over 2. Can you believe it? It's 1. One more example, or two more examples. If we look at this angle down here, so I'm going to make this angle here, which is 270 degrees, or it is 3 pi over 2 radians. I'm expecting the cos of 3 pi over 2 to be 0, and sine of 3 pi over 2 to be minus 1. Now I'll just check one of these in the interest of time, but sine of 3 pi over 2. Oh my goodness, minus 1. Now, we can't draw triangles with 270 degrees. So if I asked you what sine of 270 was before this lesson, you just couldn't do it because trig was about triangles. Now that it's about circles, we're all good to go. It's important to note that you can actually wrap around like quite far on the unit circle. So if I wrapped around like that much, actually, no, I'll tell you what, let's wrap around there. That would be an angle of 3 pi, right? Because 2 pi is a whole loop, and then we've got another half loop, which is another pi. If you want it, that's 360 plus 180 degrees, whatever that is. I would still expect that point there to be minus 1 and 0. So if I do something like cos of 3 pi, I'm hoping that gives me minus 1. And what do you know? It's minus 1. And if I do sine of 3 pi, that's 0. The other kind of cool thing you can do is wrap angles backwards. So this angle down here, I'm going to go minus pi over 4. If you want that in degrees, that's minus 45 degrees. And now, I reckon that looks like maybe minus 0.7. And since it's all symmetric, maybe minus 0.7 for the sine value as well. So let's just do the cos one to double check. If we do cos of minus pi over 4, what do you know? It's about 0.7. Oh, now my apologies. The y value was absolutely negative because it was underneath the axis. That's negative y value. The x value is still positive, so cos should have been positive there. But if I do sine of minus pi over 4, I'm expecting this value to be negative. And it is, so minus 0.7. Okay, generally we have a few really nice exact values on the unit circle. So that was one that I just calculated before. This one here is root 2 over 2, which was that 0.7-ish number that we found. They like 30, 45, and 60 degrees as their exact values, or pi over 6, pi over 4, or pi over 3 as their exact values. And you can actually work out what the other sine and cos values are just through like symmetry. So this point here is across from that point there. So I'm expecting the height to be the same at a half. And I'm expecting the x value to be the same but negative, so minus root 3 over 2, just like that. So in theory, if I do cos of 5 pi over 6, that should give me that x value that we're talking about there, minus root 3 over 2. Beautiful. And you can also work out symmetry with this stuff here. If I look at this point down to this point, I'm expecting the x values to be the same because they're the same width, sort of distance from the x-axis. and I'm expecting the y value to be negative. So 11 pi over 6, if we do cos of 11 pi over 6, hopefully, root 3 over 2, and if we do sine of 11 pi over 6, minus half. If you want some practice, I'd actually recommend that you pause the video and try and fill in all the gaps on this unit circle. There's a few missing points, and if you want, you could fill in what we just found here. So the sine value would be root 3 over 2 there, and the cos value would be minus a half. By the way, I don't want to get too much into tan itself, but a really easy way to just work it out is that tan is whatever sine divided by cos is. Now, I know that's not going to satisfy some people. So if you have a unit circle and you do want like a geometric thing for tan, you can draw sort of an angle here. That distance there will be cos of the angle. That height there will be sine of the angle. And if you draw a line straight up and you continue this black line out to that line, then that entire height there is tan of the angle, just in case you're wondering. So that's how tan works. You might also notice that if you get closer to pi over 2, closer to 90 degrees, tan will actually get really, really big. All right, last thing we should talk about here is just when cos and sine are positive and negative. So here, if I take an angle like that, it's got a positive x coordinate and a positive y coordinate because we're right of the origin and we're above the origin. So I'd expect sine to be positive, cos to be positive, and tan to be positive. Tan is sine over cos. So if you do a positive divided by a positive, you will get a positive. If we take an angle out here, well, the x value is now going to be negative. The y value is still above the axis, so it's positive. So I'd expect sine to be positive, I'd expect cos to be negative, and I would expect tan to be negative, because plus divided by minus gives you minus, because sine over cos is tan. Okay, if we're looking at an angle which is coming down here, well, let's see, the x value is negative, the y value is now negative as well. So I'm expecting sine to be negative, cos to be negative, because that was the y and the x. And then I'm expecting tan to actually be positive again, because negative divided by a negative gives you a positive. If we look at an angle down here, then we would expect sine to be negative, because we've got a negative y value. I'd expect cos to be positive, because I've got a positive x value. And I would expect tan to be negative, because minus divided by plus is minus. So you can remember that. It's handy to draw a little diagram like this. It spells C-A-S-T, or cast, if you read it around like that. And what that means is they are all positive. This means just sine is positive, just tan is positive, and just cos is positive. The others are negative, and that hopefully aligns with what we've just seen back here.